Hello everyone. Today we are about to share with you guys about the pulse modulation and multiplexing in the telecommunication. Pulse modulation is a type of modulation in which the signal is transmitted in the form of pulse. In pulse modulation, continuous signals are sampled at regular interval. The idea of pulse modulation is being raised out in the early 90s when the telecommunication network is starting to change towards the digital world. Several techniques requiring full coding of the original signal is used, such as pulse code modulation, differential PCM, delta modulation, adaptive differential PCM, and adaptive delta modulation. When digital modulation is being implemented due to its advantage and disadvantage, the advantage of digital modulation are including immune to noise, easy to measure, and be enable encryption. The disadvantage are including require a bigger bandwidth and need synchronization. Now we will share about the transmission method for both analog and digital signal. From the picture, we are conclude that when signal is going to be transmitted via digital channel, then it will need to be encoded beforehand and decode after passing through the digital channel. While the signal is going to be transmitted via analog channel, they only need pass through modem. There are a few types of pulse modulation, including pulse amplitude modulation, pulse width modulation, pulse position modulation, and pulse code modulation. From the picture clearly portrayed the different among each pulse modulation, how the pulse changes to decode the signal. Before we convert the analog signal to digital signal, there are a very important theorem need to be obeyed to get more accuracy digital signal, which is sampling theorem. A signal can be considered has been proper sampling when an analog signal can be exactly reconstructed using the sample of and the sample contain all the information needed to recreate the original waveform. There are three types of sampling method, which are ideal sampling, natural sampling, and flat top sampling.
Next, we will go to pulse code modulation or PCM. PCM is a method used to represent an analog signal in terms of digital word. In order to do so, it has to go through three processes, which is sampling, quantization, and coding. As you can see from the picture at the right, this is the whole illustration of analog to digital conversion, where analog signal need to go through low pass filter and go to sample and hold circuit, where sampling process take place, go through analog to digital converter, where quantization take place, and lastly, go through line encoder, where coding take place. Next, we have three types of quantization. The first is folded uniform quantization. It is a quantization process with a uniform quantization interval. The binary representation of bit level is always in positive value. Second, non-folded uniform quantization. It is the same as folded uniform quantization because it has fixed quantization interval. The most significant bit or MSB of binary representation determine whether it is positive or negative value. Lastly, for non-uniform quantization, it is a quantization process without a fixed quantization interval. So, it uses compression and expanding to improve its sound to noise ratio of lower level amplitude. This is the difference between folded and unfolded and non-uniform quantization and uniform quantization. As you can see, from folded quantization, the first bit in folded quantization represents the sign bit, which is 0 for negative and 1 for positive. While in non-folded, it uses unsigned number bit representation, which means all the number is positive. In uniform quantization, you can see from the picture it has fixed interval, while in non-uniform, it has unfixed interval, so it uses compression and expansion. Next, we go to other variant of pulse modulation, which is delta modulation or DM. It is a single bit PCM used to indicate whether the current sample is smaller or larger than the previous. As you can see from the picture at the left, it is the example of delta modulation. So what is the characteristic of DM? DM uses less bit compared to PCM, but it suffers from slope overload noise and its ADC output is less than slope of the analog signal. How to overcome this problem? Easy, we have to go through step-by-step solution. The first is additive DM is proposed. Then, step size is automatically reduced or increased. The next, the step size is increased until the output catches up the analog signal. And lastly, when alternative sequence of ones or zeros occur, it goes back to the minimum step size. The picture at the right represents the adaptive DM approach. So, here is a bit notes on slope overload noise. It occurs when the slope of the input signal is greater than the slope of the output, and not about granular noise is the fluctuation effect due to the decrease or increase in the step size. Next, we have line coding. The binary 1 and 0 in PCM can be represented by several formats known as line coding. The line coding format consideration is first, transmission voltage or level, second, duty cycle, third, bandwidth requirement, fourth, synchronization, and fifth, error detection and correction. Here is 5 example of line coding format. Next, we have the example of the drawing of the line coding format, and this is the summary of each format. So the conclusion is the bipolar return 0 AMI has the best overall quality.
Next, we will continue with multiplexing part. Multiplexing is a process in which multiple signals coming from multiple sources are combined and transmitted over a signal communication or physical line with a main objective to increase the capacity of a transmission channel. There is also a few types of multiplexing, which is frequency division multiplexing, time division multiplexing, wavelength division multiplexing, code division multiplexing, and space division multiplexing. For this video, we will only focus on 2 types of multiplexing, which is FDM and TDM. Now, we will start with FDM. Frequency division multiplexing is a type of multiplexing where the bandwidth of a signal physical medium is divided into a number of smaller independent frequency channels. It can be used in both analog and digital systems, and it uses different frequency carrier for different use. In FDM, we can observe a lot of internal channel crosstalk due to the fact that in this type of multiplexing, the bandwidth is divided into frequency channel. In order to prevent the internal channel crosstalk, unused strips of bandwidth must be placed between each channel. These unused strips between each channel are known as guard bands. For example, FDM can be used in radio and television transmission. Now we will continue with TDM. Time division multiplexing is a type of multiplexing where time is shared. Each connection occupies a portion of time in the link. In TDM, all signals operate with the same frequency at different times. TDM can be separated into 2 types of different multiplexing, which is synchronous time division multiplexing and statistical or asynchronous time division multiplexing. Synchronous TDM is a type of TDM where the input frame already has a slot in the output frame. Time slots are grouped into frames. One frame consists of 1 cycle of time slot, while statistical TDM is a type of TDM where the output frame collects data from the input frame until it is full. Synchronous TDM is not efficient because if the input frame has no data to send, a slot remains empty in the output frame. In synchronous TDM, we need to mention the synchronous bit at the beginning of each frame, while the statistical TDM, we need to including the address of each particular data in the slot that is being sent to the output frame. Statistical TDM is more efficiency type of TDM as the channel capacity is fully utilized and improves the bandwidth efficiency. Signaling. Signaling is a major component of any telephone system in which electronic pulses or audible tones are used for alerting, addressing, supervision, and information. In general, signaling may occur either within the subscriber loop and the local office. Signaling has been divided into 2 types, which is in-band signaling and out-of-band signaling. Let's have a look what is in-band signaling. In-band signaling is any signaling transmission that takes place within a range of frequencies that are normally used only for data transmission. When dialing from a landline telephone, the telephone number is encoded and transmitted across the telephone line in form of dual-tone multi-frequency signaling. The tone controls the telephone system by instructing the telephone switch where to route the call. These control tones are sent over the same channel as the audio of the telephone's call. In-band signaling is also used on older telephone carrier systems to provide internet exchange information for routing calls. For example, signaling system number 5, SS5, and R2 signaling. Next will be out-of-band signaling. Out-of-band signaling allows Telnet to send control characters in special situations by preceding them with IAC and sending them to the remote process. This allows urgent data to override regular flow control and interrupt an application program stuck in an infinite loop that is not accepting input. Then, what is the importance of quantization? Quantization can lower down power usage, memory bandwidth, storage usage, and increase performance. As currently artificial intelligence is highly developed, quantization helps a lot in the innovation of AI, as lower bit mathematical operation with quantized parameters combined with quantizing intermediate calculation of a neural network results in the large computational gains and higher performance. What is the benefits of multiplexing? Benefits of multiplexing is to enable network devices to communicate with each other without needing a dedicated connection between each device pair, although multiplexing still requires shared media and a better utilizing scarce or expensive network resources. For example, multiplexing can be used to transmit multiple signals across a satellite uplink or on a cable or fiber strand running between major metropolitan areas. Thank you and have a nice day.